This is problem 35, chapter 11 of Giancoli 6th edition. So again, we are playing with the pendulum. They give us the frequency of this pendulum, and they also say that this pendulum is released from rest, is starting at a certain angle. So they give us the initial angle of this pendulum, this angle with the vertical. Ignoring friction, we want to know what is the angle of the pendulum, not exactly the position, but what is the angle of the pendulum at 3 different times. Okay, so the idea is, again, they are asking us for an equation for the angle, but we know how to find an equation for position, right? How is the equation for position? Is the amplitude cosine of 2 pi frequency period. Now, I knew that it was cosine because it's released from the maximum displacement. That's release from the maximum angle means release from the maximum displacement. And so this equation is still valid, but I want to write this equation not in terms of the position now, but in terms of the angle. Remember that when we define radians, when we define angle, we know that the angle is the arc is x, divided by the length of the pendulum, which is L. So I can just write this x in terms of theta multiplied by L. Okay? Instead of the arc, I'm writing theta multiplied by L. And this is equal to, what is the amplitude? Amplitude is the maximum displacement, so I'm going to use the maximal angle, which is the initial one, theta 0 L, cosine of 2 pi frequency. The frequency is given to me, and the period. So you see the L doesn't really matter in this story, so I just found an equation for theta. Theta is theta 0 cosine of 2 pi frequency and time. So this is the equation that we need to answer this problem. Very good. Now let's be very, very, very careful here. This angle here is given to us in degree, which means this angle here will also be given, will also obtain it in degree. Okay? Now, what you have to be very, very, very careful is that this 2 pi frequency that is showing up here is the angular velocity, and angular velocity is given in radians per second. Okay, radians per second. So this means that what we'll be solving is the cosine of a number that is given in radians. Once we multiply by the time, this second will disappear. The number that we'll be playing with is radians. So you have to set your calculator to compute the cosine of a number given in radians, okay? The angle here, the theta here, will be in degree because the initial angle here was given in degree. But to find these numbers, you have to solve the cosine of a number in radian. Okay, if you don't put radians here, you're not going to be able to get the right number. Okay, once you understand that, then you just solve this cosine of this number for those 3 different times.